Hi, Assalamualaikum. My name is Ahmad Eza bin Alwi and my matrix number is 2022697166.
My name is Tuan Muhammad Fatul Naim bin Azuddin and my matrix number is 2022457092.
Hello, I am Muhammad Adifidai bin Muhammad Fauzi. My matrix number is 2022873874.
I am Amir Faiz bin Saiful Bahari. My metric number is 2022642518.
Hi, my name is Muhammad Amirul Azhar bin Ibrahim. My metric number is 2022829742.
For introduction, a simple statement will consist only a statement in which has one subject and one predicate. It is also known as primary statement. A few primary statements can be combined to form a compound statement. The truth value of a compound statement is completely determined by the truth values of its primary statements. The primary statements are combined using connective logical operators to form a compound statement. There are 5 logical connectives. The first one is conjunction, which in the statement called AND. The second one is disjunction, which in the statement called OR. The third one is negation, which in the statement called NOT. The fourth one is conditional or implication, which in the statement called if, then. And lastly is biconditional, which in the statement called if and only if.
Okay, next we move to the next table. We have the variable P and Q, and also we have negation, conjunction, disjunction, conditional and biconditional. Okay, let's say the first row, P is true and Q is true. Then we negate the P, we will get false, from true to false. Then P and Q, which is true and true, we will get true. If P or Q, true or true, we will get true. Then P implies Q, which is true implies true, we will get true. And biconditional P biconditional Q, that is true biconditional true, we will get true. The second row, negation of P, from true to false. Then we have P and Q, that is true and false, we will get false. Then we have P or Q, that is true or false, we get true. Then we have P implies Q, that is true implies false, we will get false. Then we have P biconditional Q, that is true and false, we will get false. Okay, the third row is negation of P, from false to true. P and Q, which is false and true, we will get false. P or Q, that is F, or that is false or true, we will get true. P implies Q, that is false implies true, we will get true. And biconditional P implies Q, we will get false. Biconditional true, we will get false. Okay, the last row is negation of P, from false to true. We will get P and Q, that is false and false, we will get false. P and P or Q, we will get false or false, we get false. P implies Q, false implies false, we get true. And the last one, P biconditional Q, false biconditional false, we will get true.
I will explain about tautology, contradiction, and contingency. First is tautology. Tautologies are statements that are always true. For example, either it will rain tomorrow or it won't. Second is contradiction. Contradictions are statements that are always false. For example, the triangle is a circle. Last is contingency. Contingencies, often called contingent statements, are true in some cases and not true in others. For example, if you have a cat, you won't have mice. For example 1, we know that P is Ali is hardworking, Q is Ali passed the exam, and R is Ali is playing the football. The question is to define the statement. If Ali is hardworking and not playing football, then he will pass the exam. In symbol. Okay, first, Ali is hardworking. the symbol is P. Next, and not playing football. The symbol is symbol for next, symbol for not, and R. Next is then he will pass the exam. The symbol is symbol for if then, which is right arrow, and Q.
For example 3, we have to construct the truth table for the statement P or Q implies not P. So we create a column for P, Q, proposition not P, proposition P or Q, and proposition P or Q implies not P. For P, the truth value is true, true, false, false. For Q, true, false, and not P, we just negate the P statement, which is false, false, true, true. For proposition P or Q, if both statements are true, we got true value. If one of the statements are true, we also got true value, and if both statements are false, we got false value. So the truth value is true, 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 false. For the last proposition is P or Q implies not P. The truth value is false, false, true, true.
And lastly, example 3. The question is, verify whether the statement P and Q implies P or not Q is a tautology, a contradiction, or a contingency. By using truth tables, firstly, the truth value of P is true, true, false, false, and the truth value of Q is true, false, true, false. And then we check the true value of P and Q, which is P and Q first. When P is true and Q is true, then P and Q is true. When P is true, Q is false, then P and Q is false. When P is false, Q is true, then P and Q is false. When P is false, Q is false, then P and Q is false. Next, we find the negation of statement Q. When Q is true, then not Q is false. When Q is false, then not Q is true. Then we find the true value of the statement of P or not Q. When P is true and not Q is false, then P or not Q is true. When P is true and not Q is true, then P or not Q is true. When P is false and not Q is false, then P or not Q is false. When P is false and not Q is true, then P or not Q is true. And lastly, we will find the true value of statement P and Q implies P or not Q. When P and Q is true and P or not Q is true, then P and Q implies P or not Q is true. When P and Q is false and P or not Q is true, then P and Q implies P or not Q is true. When P and Q is false and P or not Q is false, then P and not Q implies P or not Q is true. When P and Q is false and P or not Q is true, then P and Q implies P or not Q is true. For the conclusion, since all the true values are true, therefore the statement is tautology.
As for conclusion, we use symbols to stand for the relationships between statements. This is to indicate the form of an argument. These relationships are made possible by logical connectives such as conjunction, disjunction, negation, and conditional. Connectives are used in compound statements, each of which is composed of at least two simple statements. A statement is a sentence that can be either true or false.